I wonder if hold on. Oh, that's why I didn't hear anything. Okay. All right. So this is 2-3 day 2. For those that were missing yesterday, period 7, no excuses. I had a video that you were supposed to watch, and guess what? You have to do it tonight then. But anyway, Jake. Okay, what's the factorization of this? And I'll explain the answer. What does this factor ought to become? It's it. I mean, if I see 4 steps for this, I'm going to cry on your paper or maybe throw up on it. Okay, because it's just 1x squared. So it is whatever multiplies to negative 12, and then those same two numbers add to be negative 1. It's negative 4 and 3. But that means the factorization is x minus 4x plus 3. Good foilers, say it. The point of this comment is you check your answer. Sure x squared, sure negative 12, 3x and negative 4x, that is negative 1x when you add those as like terms. You being in CAD, I should not have to explain that again. All right, as far as how that answer actually makes sense. Okay, so yes, we're being rough. Let's go to B. Now let's see who gets the terror of the calculator pick. We'll give them a second to breathe, and then that is Kathleen. Project that voice, Kathleen, so I can hear you, but I want you to try this. And by the way, as Kathleen thinks about this one, I personally like pick the homework assignment, making sure it matches exactly what we're doing. And what we're doing right here matches what we have to do for 33 through 38. More about these bottom ones, but the idea of factoring, we need to practice it real quick. All right, Kathleen, we're going to zoom in on this. I really want you to try it this way, but hopefully you already have the answer. But what equals 3x squared? What has to go here and here? What has to go in those two positions? X and? So what times what equals 3x squared? I can't hear you. X and? So x times what equals 3x squared? Are you saying 3x? Okay, I can't hear you. You got to really throw that voice out. Otherwise, I have to keep running at you here. All right, so we definitely have this. And then did you tell me what your first factor is if you actually did this? X minus, did you say, I can't hear. X minus 9? See, you did a thing. I know exactly what you did. This is what you did. You did 3 times 6 equals 18. So you're doing the 4-step process, but then you stopped short. Because you said that x minus 9 is one of your parentheses, and then probably x minus 2. Is that what you put? Yes or no? That can't be possible. Good foilers, say it. Good factors. What is x times x? Is that 3x squared? Yes or no? No. So that cannot be your answer. You stopped short on a method that was told to you last year. We need to be good foilers, good factors. This is actually what your answer should look like. So I'm going to continue with your thing. This is what you should have done. It should have been 3x squared minus 9x minus 2x if you are going to go this 4-step method of factoring. This is rewriting that, still equivalent to the original, but busting up those terms with those magic numbers that you got. Darn it. And I forgot to say yeehaw like a cowboy on Cowboy Day. How many people dress like a cowboy? How come you don't wear your hat? Anyway, next thing, plus a negative. I got to get the pen going. And then, Kathy, I'm going to make you do this. What do I pull out of that first one? What is the GCF? Say it loud. 3x, good. And then I'll do the rest. It's x minus 3. And then, Kathleen, you got to take out, well, actually it is. What do you take out of this one? It is negative 2. Very well done. So this is what you missed. I want you to see this one more time, that we should never, ever, ever, ever be writing this as a final answer for the factor form. Ever. Because good foilers, say it. Good factors. That could not possibly be the right answer. Not possibly. All right. And then when you look at what I have left over there, it's x minus 3, 3x minus 2. Good foilers, good factors. 3x squared, negative 2x and negative 9x is negative 11x. And then negative 3 times negative 2 is 6. I actually did reference that, Kathleen, last hour, how many people do what you actually did. And it's okay. We got to get it out of your system, though, is what we got to do, and make sure we go from there. All right, next, let's see. Enter. And I don't care how long this takes. It seems like factoring is that lost arts that I kind of said. Adam, what does this one definitely have before I start thinking about factoring this? Or what is the first thing you should always look for when you factor? You take out an X, that's a GCF. And then did you get a final answer for this when you took the second step here? Okay, well then what did you end up getting for a final answer? Because really this is what we should do. We should aspire to say, okay, I know this is 3x and 1x. I know it has to be that. We should just undo it. What did you end up getting for a final answer? 3x minus 2 and x minus 1. And that's one of my tests. Somebody said, okay, what's a product that equals 2? It's got to be negative 2 and negative 1, right? And then check the middle term. All right, I'm good to go. Negative 3x and negative 2x is negative 5x. Good FOILers, good factorers. Notice this section just says factor and put it in linear factors. Doesn't say solve. First of all, what's missing? If it, for this to be a solve, there is no what kind of sign. There's no equals. I get people that go the next step and say, for over here, x equals negative 3 and x equals 4. This is not a solve. This is factoring. So get that separated in your brain. This is a solve. To find the zeros of this, we do set this equal to 0. And then we actually solve this, which means we factor first. Then we use what's called the zero product property. All right, let's grab a student, not physically, but let's get one on the calculator. 18. Who's 18? 22, 21, 20, 19, 18. Nathan? Nice. Did you already factor this?
No.
I'll tell you what happens on this, Nathan. It's definitely 3x and 1x again. And then what equals negative 4 here? Like, what are you going to try? What do you think goes in each set of parentheses if you can undo it? You can always trial and error and then erase what a pencil's for.
With a negative 4.
So you're going to put negative 4 first?
Yeah.
And then what would have to be here then?
1.
Okay, but then does this give me the middle term that I want? Yes or no?
No.
No, it doesn't. So we need a different product. This is how you can do it, and it's fine. All right, so what else? What do you think it should have been?
Negative 1 then?
Well, did you get a difference? Like the difference is only 1 or negative 1. We need a difference that's 4. So I reject the 4 and the 1. What else multiplies to 4? 2 and 2. And let's check if our signs are in the right spot. So first of all, negative 2 times 2 is negative 4. All right, and let's see if we have to change the signs. Do you like this one? Yes or no? When you look at the outer and the inner. Did you say no?
Am I supposed to say yes?
You were supposed to say yes. What's 3x times 2? What's 6x, and then what's negative 2x? What's 6x plus negative 2x? That is 4x, so it is the correct factorization of this.
Okay.
But now we're going to take it a step further and solve for this. All right, so we're going to solve. Okay, so you get this in factored form. I hit enter. I missed it. That's me. Who's 20? Nice, Ivo. You're into his house here. All right. First of all, Ivo, what would this be as an x-intercept or a 0? Solve for that. It is negative 2, but actually it would be at negative 2 comma 0 as an x-intercept too, right? So, okay, fine. I'm jumping the gun here. But x equals negative 2, and then set this equal to 0 and solve. I tried to write negative 2 3 times. What does that end up being?
The first one?
Yeah, the first one. What does this give me as a 0? You are correct. Add 2, divide by 3. But then I'm going to do this for my 7th hour. I am going to sketch this real quick. I'm going to tell them what they should know after watching my video yesterday, which they probably didn't. Okay, or at least the majority didn't. And then they want to make excuses. Not just 7th hour. It's the general student that doesn't do what they're supposed to and then think it's everyone else's fault. All right? By the way, this is a picture of a what? What is this a picture of? A 3x squared. It's a parabola. Which way does it go? Up or down? 3, 2, 1, go. Up. Majority of you should know that. Wrong. Everyone should know that. All right. So here is the sketch for this. Now I know we have tools to find the vertex. We're not focusing on that right now. I will ask you questions on the quiz Friday specific to 2-1. This isn't 2-1 anymore. We're making sketches. All right, so that's what you learned yesterday. Factors turn into zeros, which turn into x-intercepts, right? Okay, now the next thing. Who's this person going to be? All right, like keeping you on task here. 7. Who's 7? That's Ella. First of all, Ella, what's the first thing you should do in this factoring here? More. You're going to make your factoring tough if you don't take out what else? But go ahead and do it, and then I'll tell you why their factoring's better. You take out a 5x, and then you're left with x squared minus x minus 2. Now change it. Just now answer my question. What multiplies a negative 2 and at the same time adds to negative 1? What are those two numbers? Say it again. Which one's negative? Sorry. And then that's what the factorization of this is. And then I'll take it from here. Well, actually, you should take this from here. What is this as a 0 then? Let's take that middle one first. What does x equal? And then everyone forgets about this one. I'm doing this on purpose to make a point of this one. Do you know what x equals for that one? 0. That is actually a number. That is actually a different x-intercept than 2 and negative 1. So we need to not lose this one. This one is a common error. A lot of people lose that. And I had that in our notes yesterday. I made a big point of it. I really try to make big points on common student mistakes. Then let's go back up to here. We should know from yesterday, 5x cubed. A 5x cubed looks like this. Woo, right? And behavior, I could do my hands up here, A, B, C, or D, but we should know that from yesterday. 7th hour, they better know that. All right, but we'll see. 0, 0, 2, 0, negative 1, and then this is how it fits. By the way, there's no multiplicities. Okay, fine. Multiplicity 1. Nothing special. It just goes straight through, all right, for each one of those zeros, and it fits the picture that I was supposed to have. So I know this doesn't say graph. This was the answer to the question in the notes. What I'm doing is taking it a step further so that my 7th hour understands some connections between the 2 days. Jake, are you okay there? All right, man, I always look down there and it looks like he crashed his head off his desk. Okay, now, feel free to write this down. These are a bunch of synonyms. That's cinnamon, delicious, on your pancakes. Solution. That's what we just found on that factoring and then solving. This is the weirdest word ever used for that. Root. Okay, a solution is a root. I don't know, I would say root, but it's probably wrong. Which is a 0 for the function. And then what that turns into for the graph is an x-intercept. So here's what I kind of have to say for this. For these, k is a solution, root, or 0. But then when we turn it into an x-intercept, it turns into a coordinate, k comma 0, right? So that's the minor syntactical difference, but then also, what kind of question it answers. And then you should be able to toggle back and forth between this and this. As a factor, I know it says it right there. This is what kind of polynomial do I have when I have a given 0. That's how the 0 turns into a factor. This should not be a big jump. Look, I just asked the 2 previous people in the bell work here. If x plus 2 is a 0, then negative 2, the factor, then negative 2 is a 0. Well, look at going backwards. You should be able to say if negative 2 is a 0, then x plus 2 is a factor. All right, our notes are going to end with this idea, reversing this question. All right, and that's what's kind of important for this. The whole encapsulation of the section 2-3. We can really move on in 2-4 and 2-5 and do a lot more stuff with this. Okay, so 5th hour should be able to handle this because of yesterday's glorious notes. So arrogant about his notes. Those weren't even my notes. I told you I stole it off the internet because I love them. Evan, right? Evan, are you here? Where are you going? You've had enough? Oh, I thought you were just like, that's it. I'm out. So if I were to plug in 0 for this, I don't feel like writing this. Here's what I'm going to do. Then what would the solutions be for these 3 factors? Hey, let's take this last one. What would x equal for the last set of parentheses? It would be -1. But then now I'm going to go backwards. What about 4 minus x? What would be the 0 for that one? It is 4. So it is a little switcheroo on that one. And then what's this first one, which isn't that hard? I just wanted to do the fraction last. 3 what? Oh, yeah, 3/2, not 2/3. Add 3, divide by 2. So those are all my x-intercepts. So it does say graph. And and I don't know why my graph is so far away. So 4, 0, go ahead and make just a simple sketch. -1, 0. And then 1.5 is 3/2. By the way, all these multiplicities are 1. And I'm going to turn them into x-intercepts just to formally say zeros turn into x-intercepts, and that's why I'm allowed to graph them. But here's my next thing, and I'll get someone different than Evan, so you got your answer. And I love this hour because most everyone gets to go then. Student number 8, that is in the back, Dana. Dana, I got a tough question for you. She's like, oh, great. First of all, if I were to multiply this out, what would be the degree? It'd be x to the what? We'll start with the easier of the 2 questions. What would be the power? 3. Now, not as easy. This is the first time this happened. What would the leading coefficient be? I'll highlight what you need to focus on. Ultimately, this will be multiplied by this and that. And then that's what the leading coefficient will be. Nice. That's very important to get the -2, the minus. So this is, if I foiled this out, ultimately those 3 things would be hit. So everybody, okay, I should put this in and making sure. Are you okay over here? All right, cover the nose. Okay. All right, so A, B, C, or D. Ready? A, B, C, or D. What's the right answer? 3, 4, 3, 1, go. B as in boy. All right, good. And if you didn't answer, that's how I feel about you. It is true. I'm tired of it. You were all here for the notes yesterday. And if you weren't, you should have watched the movie. Mr. Samuelus. All right. And then all of these multiplicities are nothing special. So it's straight through, straight through, straight through. This is really the main crux of the test or quiz on Friday with some other stuff, some algebra, some factoring and foiling. I'm going to check your factoring and foiling skills. I don't think I have to do all these. I'm going to cancel this one. I'm going to move into this one. I'm kind of annoyed that the graphs are so far away. Should close this off and then slow down, making sure that they know, or I know that you guys have to take these down as we go. Staying invested in your education. Hey, I just asked you, are you okay? Then your number came up. All right, so let's turn them right into x-intercepts. What's this x-intercept? Comma. And then what's this x-intercept? Comma 0. And then what's that last one? So simple, getting the x-intercept. What are the multiplicities? Let's make sure we write that down. What's the multiplicity of this one? This was the big idea yesterday. Say that number. So what's this multiplicity? I shouldn't have to circle it. And then I don't like having to say this one. This is a multiplicity 1, which nothing special happens. Now I'm going to put you on the spot for yesterday's notes. What happens at this 0? Does it cross through or does it bounce? I gave you 50-50. This is a bouncer. So this is from yesterday's. This is all you had to get out of yesterday. What's the next one? Does it cross through or bounce? It crosses. Here's what you need to do, though. It crosses. Then again, this is only if you did last chapter correctly. It crosses like a cube. It crosses like an x cubed. It's got that flattening like our family of x cubed functions, but just in that one little area. And then the last one, this certainly just crosses. and there's nothing special. It just flows right through. Okay, so that's what we need to do. Oh, and then let's bother somebody else. What's the leading coefficient and the degree? 7. That Dana or Ella? All right, it gets you to Dana, Ella. You both end in an A. You're right next to each other. All right, so sorry, it's Ella, correct? Ella, what is the leading coefficient and then the degree on that when we're done multiplying this out? Oh, it would just be 1x times 1x times 1x times 1x times 1x times 1x. So you did degree. Okay, I got you. I'll put that in then. All right, you got the degree when you said 6. Okay, right? Because that is the degree. And that's what you end up having. Okay, everyone. A, look up here. A, B, C, or D. 3, 2, 1, go. C. And if you didn't answer, all right, it's C. Got some special stuff in the middle, but that's how it's got to end. Now, when you put this all together with what we did over there and what that A, B, C, D thing, this is what the graph should be. 2, 0, -1, 0, and 3, 0. Unfortunately, these zeros are pretty close. All right, so it's got to end up. So this last 0 to the left, I got to come from up here, and this is the bouncer. Bounce. And then I'm going to stop and think about this for a second. Wait, did I do that right? Wrong, Mr. Samulus, wrong. This is the first 0, which crosses like this. My bad. Sorry for yelling in YouTube. That's how a cubic looks. It's got that cubic little flattening. Don't get all crazy with this wobble in the middle here. Just flatten it out like the cubic family of functions. So -1 was cubic. 2 was the bouncer. So it does come up and bounce off of this 0, come down a little bit, and then come straight through the last 0. And then that's what that polynomial function sketch would look like. When you're sketching, I don't care how low these loops go. We can do something with the calculator to find out what those are. This is all about sketching through 0 analysis. We already did this. Multiplicity that's even is a bouncer. Multiplicity that's odd crosses. But just make sure when it's larger than just x to the first, if it's cubic or 5th power or 7th power on those, it just crosses like a cubic. Just flatten it out. All right. And I guess I'll do. I really don't feel like I have to do this one, but I guess I will real fast. So first things first, don't get confused with the 7. The 7 is just the leading coefficient after I distribute. So as you're writing this down, I'll leave you alone until I get to the end here. This is 7x to the 5th. Just a time check real quick. That can't be right. All right, 20. 9 minutes. All right, so we should know that's a 7x to the 6th when we're done. All right, that 7 is not one of the zeros. Some people say 7, 0. No. All right, and then if I asked A, B, C, D, it'd be C. Ends up like this. But here's what's interesting. X minus 3, 3. X plus 5, -5. Both of these zeros are even multiplicities. They're both bouncers. So for me to get this to happen with these zeros that I have with only 2 of them, this is what would have to happen. You don't have to show this, but a 4th power bouncer is like a little bit flatter than a x squared bouncer. That is truthful, but I don't really care. You just got to show the bouncing. Got it? And then that fits what should have happened, how the end behavior should go. I'll tell you, these loops are crazy. They're off the charts. They're way high. You're just making a sketch, all right, to fit the zeros. We're going to hold off on that, not yet. We'll use the graphing calculator a little bit more later. And then look at I put the numbers for the homework. And I did 56. 56 is a doozy. You know what I might do? I might do, after the bell rings, I might do letter C. And then a question like number 56 would be extra credit on Friday. separate the real mathy people that are dominating this class, give them a chance to show their stuff here, show their math acumen. Ooh, that's a word, acumen. All right, remember when I talked about zeros? Zeros turn into factors. Now to move this off to the side here, and hopefully fit this to the left. But let me get one more student, last one of the day, who almost got away with it. Adam, haven't you already gone? Oh, bummer. Okay. All right. So if 3 is a 0, Adam, then what would be the factor where that 0 came from? You got it. So you did this last year, I think, too. And then -4 would be what? And now I'll tell you where the directions are kind of bad. What's this one? The directions are bad because they don't say two things. I will make sure that it says it on the quiz. Find the cubic function in standard form. That means you have to multiply it out. Another thing that they're missing is that leading coefficient just equals 1. Because if it didn't say that, this question is actually a little bit harder. So notice when I wrote this, just those zeros that I have there, then the leading coefficient would be 1, and then I could just continue. Good FOILers are good whats? Guess what? You got a FOIL now. So that's why it's the reverse of what we just did in the beginning of these notes. And I'll go ahead and do this real fast and leave students alone after this. Because really, this is, you can watch me. I shouldn't have to explain this. You're in CAT right now. If you can't do this, this is why CAT is a problem. And we don't have the time to stop class, and this is where you got to go somewhere. You got to go to tutoring or whatever if you're struggling with foiling and multiplying. We had this in Chapter P, by the way. We already tested you on doing this, so it was taught before. I stopped here because, yes, you want to add this middle term. And then the next part is not hard. It just takes a little bit of organization. I draw the lines. Why wouldn't you? People that get these wrong do not draw lines, do not structure themselves, and they cause their own demise. And that's where my patience goes away, all right? Because this really shouldn't be that hard. So notice the lines that I'm drawing as I do each distribution, and you could call this distribution instead of a cousin of FOIL. It keeps track of all 6 of my multiplications. All right, and then I do kind of have to speed it up as we have 4 minutes left. I got to get my like terms together. And there's the polynomial that has those 3 zeros, but in standard form. Now, you're not going to believe this. The next example is actually easier than this. I should bully someone. It's not bullying. I want to make sure people are taking their notes or invested in their own education. But I should ask everyone, if root 2 is a 0, what is the factor? 3, 2, 1, go. X minus, root 2. It's x minus root 2. Root 2 is a 0. It's actually approximately 1.4. It does cross the x-axis at 1.4. So this would be very graphable. And then if negative root 2 is a 0, then x, go ahead, tell me what sign I put. Minus or plus? Plus. Because if 4 is a 0, it's x minus 4 is a factor. So that's what they are as factors. The exact reverse of the beginning of our notes. You need to understand that. All right, and then you'd be a fool if you didn't multiply these first two. Because watch what happens. The conjugates, if you will, that's what this is actually called. Root 2 and negative root 2 are called conjugates of each other. You don't have to worry about that term. But hopefully you remember that term. What happens in the middle term as I keep going here? What happens in that middle term? Cancels. All right, now here's the thing. Negative times a positive is a negative. be perfect timing for me to keep going with the video for the extra credit people. What's root 2 times root 2? Root 4, but what's the square root of 4? 2, so it's 2 actually. And then don't be a fool and start trying to multiply. Cancel. And then notice that you have another FOIL now. That's why this next question was easier than the one before. Really is. And then g of x equals x cubed minus 4x squared minus 2x plus 8. Right? All right. Now I'm going to wait for the bell to ring. At this point, shut down the video if you don't want to go above and beyond the call of duty and try to get an extra credit question. I'm actually going to make up something here, though. As people are putting their bags away, I want them to notice something on the first two, the first foil. Remember, I foiled this to get this. Okay, watch, listen, and learn. You guys might find this interesting. When 3 and negative 4 are the zeros, notice the last term in this polynomial ended up being the product of these two zeros. I'm going to use this on my last example. Notice that the middle term was the opposite of the sum of these two zeros. What's 3 plus negative 4, everyone? Negative 1, but notice this is what kind of thing? 1. So here comes the extra credit here, and I know Math 3 Honors does this. Math 3 Honors takes this process about how I could actually trick myself and not have to foil if I can remember this trick. So, first things first, zeros come in conjugate pairs if my polynomial is going to have real coefficients. So this is going to be something we'll do in section 2.4 called the complex conjugate theorem. So if 1 minus root 3 is a 0, then 1 plus root 3 is a 0. And then this is all I'm going to do. I'm going to show you what Math 3 Honors students do. First of all, x minus 7 is not a big deal. Here's the problem. Oh no, x minus 1 minus root 3. And then x minus the conjugate 1 plus root 3. Okay, I guess I could do this. If you're really listening, you could survive this. You could survive this. Then I'll show you the product and something. I'll show you it, and then you'll be amazed. And if you can remember it, you'll get this question done pretty quick. Fine. I think the smartest thing for you guys to do is distribute this minus sign, and then do a 9-step multiplication. And actually what I'll do is I'll put this in brackets now. But what I made, those parentheses on the inside, I made them meaningless. So I could just start foiling. No, it's not really foil. X squared, negative 1x, negative root 3x. That's 3 out of 9. Negative 1x. And I'm getting upset. This is not hard. Okay, this is just something you follow the lines, you follow you make all minuses plus negatives, and everyone should be able to do this cousin of foil thing. People see like 4 lines. That's more than I can't do that much work. Well, then that's on you. That's all you, man. All right, negative 1 times negative 1 is 1. And then negative 1 times negative 3 is positive root 3. Oh, this is getting nuts. And then last but not least, maybe I'll change the colors. This is positive root 3x. Oh, look at what we got for terms. This is negative root 3. Look at what we got for terms. What happened there? And then just like that last one, negative root 3 times positive root 3 is negative 3. And notice what we ended up getting. These are opposites of each other, negative root 3x and positive root 3x. Root 3 and negative root 3 are opposites of each other. And then what I end up having is x squared minus 1x minus 2x. And then I have 1 and -3, I think, which is -2. I hope I got that right. Okay, 1. Yep, perfect. Now, notice what I said before, but this is kind of stinky. The sum of these two zeros, the sum of those two is 1 plus 1, 2, and then the root 3's cancel. Notice this is the opposite of the sum of the two zeros in that position. This is what Math 3 Honors do. Math 3 Honors memorizes that so they don't have to do any of this. Quick, fast, efficient. And then this is actually the product of the two zeros, including the negative, and we're going to prove that. The product of these two zeros is 1 times 1, 1. Negative root 3 times root 3 is -3. The middle term falls out. So those that are still listening, you should understand that the middle terms fall out, and that is the product of the two zeros. So whenever you have two zeros, 0, 1 and 0, 2, when you find the polynomial that those two zeros make, it's always x squared minus the sum of those two zeros, x, plus the product of those two zeros. Feel free to use that on this particular question. It does work. Oh, and by the way, you have to FOIL again. Not FOIL, distribute. It does anger me how many students are saying this is above and beyond the abilities of them in a CAT class to just follow these lines after that. This is separating, the students that just barely, were in honors or just barely, you're really solid with your math. You're going to take calculus next year. This is all valid math skills that, you could take with you. Hopefully, I'm trying to do two things at once. Hopefully, I didn't make any mistakes there. So x squared minus 2x squared, or x cubed. Oh, there's mistake number 1. Nice. Good catch, Mr. Samuelis. Minus 2x squared, minus 2x, and then 7x squared negative, 14x, and then 14 positive. That's another mistake. Whoo! Can't chew gum and walk at the same time, Mr. Samuelis, apparently. Trying to do too many things at once and I'm making multiple mistakes. Hopefully there aren't any other mistakes. Double check some stuff there. Okay, so that's what the function would end up being with those three zeros, right? Not saying this is bad math. This is certainly something you could certainly do in order to get that first polynomial, right? We'll see. I'll definitely put it in the extra credit.